It seems today AI is everywhere. Every product and service, regardless of need, now seems to boast its AI capabilities. And the public's reaction to AI has been varied, to say the least, with some enthusiastically adopting it from many or all aspects of their life, while others choose to use it either sparingly or not at all, over concerns ranging from ethics to practicality. With the CEO of Microsoft admitting that AI must have a wider, presumably positive impact, otherwise social permission for its heavy resource usage will be lost, this got me thinking about how large an environmental impact AI is actually having. I already knew it would be significant, but what I found really shocked me. Hi, I'm Dr. Eleanor Tufnell, an environmental scientist. In this video, I'll be covering the different environmental costs of AI, including energy and water usage, as well as chemical, heat, sound, and noise pollution. I'll also be discussing what can be done about these issues and what challenges we face in doing so. Neither blame nor absolution. I shall acknowledge early on that there are a lot of potential concerns with AI, including legal, ethical, practical, economic, cybersecurity, psychological, and neurological. Most of these are outside the scope of this channel, but I didn't feel right not mentioning that they exist. AI has also been used to great effect in certain research fields, from the AI that was initially trained to identify pastries that turned out to be great at spotting cancer cells, to the decoding of the language of whales using AI. I also want to note that the term AI is doing a lot of heavy lifting here, and can be applied to an exceptionally broad range of technologies. In this video, I'm generally referring to generative AI, which itself is a broad term and refers to AI where the primary function is to generate content, for example, generate images, code, audio, or text, rather than, say, classifying data, grouping data, or choosing actions, though AI tools are also used to handle these tasks. Full disclosure, I'm an environmental scientist, not a computer scientist, so do not expect an in-depth analysis of AI technologies themselves from me. I'm largely restricting myself to discussing the environmental impacts of AI. At some point in this video, someone who uses AI may feel compelled to jump into the comments section, explaining precisely why their use of AI is okay. They just use it for this or for that, or they need it because of X. Now, you're entirely free to do this, and I welcome the engagement, but I need to state here that my goal isn't to wag my finger disapprovingly at you for using AI, nor can I provide absolution for it. While I absolutely do have my own opinions on AI and its usage, my purpose here is to provide you with the facts on its environmental impact and leave you to make up your own mind about what to do with them. The water cost. AI systems consume a massive quantity of water, in no small part due to the fact that they need it for multiple purposes. Water is needed to keep the servers and related components cool. Water is indirectly consumed in order to generate the electricity needed, more on that later. And water is used during the manufacture of the hardware needed for AI data centers to function, such as servers. Concerningly, the water used for cooling is not easily reused. The water that isn't evaporated is contaminated with dust, chemicals, or minerals, which means it becomes unsuitable to reuse for cooling. It can theoretically be treated and either used for purposes like irrigation or released into waterways. However, as we'll see in later sections, there are reasons to believe water is not being treated sufficiently to prevent harm to either the environment or humans. But how much water is used? That is difficult to ascertain, particularly for indirect water usage. Tech companies aren't always transparent or forthcoming on their water usage. Data center operators often do not distinguish between AI and non-AI workloads in their environmental reports, making it tricky to accurately estimate how much water or power is directly related to AI. There are also a number of factors that impact how much water is used per prompt, for example. As more cooling is required in warmer temperatures, water usage will fluctuate over seasons and time of day. Where the data center is located and the length and complexity of the prompt also impact how much water will be needed. Estimates vary, but let's break this down a little. A single prompt to a large language model that generates a roughly 100-word response uses somewhere in the region of 500 mL of water, roughly the size of a standard water bottle. If we imagine 1 million users were to send 10 prompts a day, this would add up to 5 million litres of water a day. Many large language models boast weekly active user numbers in the hundreds of millions. So if we assume 400 million users, that's 2 billion litres of water a day, 14 billion litres a week, and 73 billion litres of water a year. That is just rough back-of-the-napkin maths. A recent study estimated that the water footprint of AI systems in 2025 could be in the range of 312.5 to 764.6 billion litres, potentially exceeding global annual consumption of bottled water. That's a gargantuan amount of water. And as most AI systems seem to be increasing their demand every year, if the status quo continues, this will only get worse. Global AI demand for water is predicted to be 4.2 to 6.6 billion cubic meters in 2027, which for comparison is half the UK's annual water withdrawal, or the total annual water withdrawal of Denmark. While some of that water may be treated and released back into the local water systems, a certain amount will be lost to evaporation. And remember, this is clean, potable water needed as drinking water. And it gets worse, because this would be bad enough if data centres were built in areas with plentiful water. In the UK, 84% of new water-intensive data centres are proposed to be built in areas that are already under water stress. Globally, around a quarter of existing data centres and a third of data centres under construction are in areas expected to experience water scarcity by 2050. That's water needed for vital purposes such as human consumption, agriculture, and natural habitats. We are already seeing data centres using so much water while local communities face drought restrictions and shower limits. Can anything be done to improve the situation? Well, there are a number of ways to make building data centres more sustainable. Innovations in technology have meant tech like liquid immersion cooling and free cooling are better able to address the direct water usage of data centres. Alternative methods also include air cooling, though this also carries an added energy cost. More on that later. New data centres should be located in areas that are neither under water stress currently nor at risk of experiencing it. Data centres could use closed-loop cooling systems designed to reuse water and minimise loss. They could also utilise rainwater. Many companies have admitted their water usage is an issue, and as it will be costing them money, there may be some immediate financial incentive to improve matters. But at present, advances in efficiency are still being outstripped by demand. Without continued pressure to become sustainable, most will be slow to do so. The power cost. AI systems need power. How much power is difficult to accurately estimate, for reasons already discussed in the last section. But I found a few reasonably reliable estimates. Training of an AI alone takes massive quantities of electricity. The estimate for OpenAI's GPT-4 was 50 gigawatt hours of energy. That's enough to power San Francisco for 3 days. Estimating how much energy is used for every prompt is a challenge because multiple factors affect it. The type and size of the model, the type of the output, which energy grid the data center handling your prompt is connected to, the time of day, etc. All affect how much energy is used and can make a prompt's energy and emissions impact increase by orders of magnitude. One report by MIT Technical Review gives an overview of what daily energy usage might look like for someone with an AI habit. Say you ask the AI 15 questions on the best way to fundraise for your charity marathon run. You have it create some flyers for you, and then after 10 attempts you find one you're happy with. You then need a 5-second video about it to post on social media, and you make 3 attempts before you get something you want. How much electricity usage would all that add up to? Roughly 2.9 kilowatt hours. For perspective, that's enough to run a microwave for 3.5 hours, ride an e-bike for over 100 miles, or drive an average electric car for about 10 miles. And that's just one person mucking around asking a few questions and getting a few images and short videos. Given that the average weekly active users of many language models are in the hundreds of millions, that's going to add up fast. Business Energy UK breaks down prompt electricity usage and uses the estimate per prompt of 0.14 kilowatts for every time an AI generates 100 words. Assuming 400 million active users, well, this adds up to 40 million kilowatt hours per day, 280 million kilowatt hours per week, 1.2 billion kilowatt hours per month, and 14.5 billion kilowatt hours per year. That's a lot. A report published by the Lawrence Berkeley National Laboratory in December 2024 predicted that by 2028, over half of data center electricity usage will be for AI. That would mean that AI usage would consume every year the same amount of electricity as the combined consumption of 22% of US households. Data centers are predicted to account for 35% of Ireland's electricity use by the end of 2026. Some estimates are predicting that within 3 to 5 years, the power consumption for data processing will exceed that budgeted for manufacturing. But how does this compare to a standard Google search? Well, the International Energy Agency estimated that a single ChatGPT request typically requires 10 times more electricity than a regular Google search. If you're wondering how that translates to CO2 emissions, a recent study estimated that the carbon footprint of AI systems in 2025 was between 3.6 and 79.7 million tons of CO2. As New York City's CO2 emissions in 2023 were approximately 52.2 million tons, AI systems are already contributing similar levels of emissions. Now, how much of an impact AI systems have on CO2 emissions will vary depending on how clean the energy source was, and improvements to energy efficiency could significantly reduce the energy required by data centers. Theoretically, if all AI systems got all their energy from renewable energy sources, their energy use would not contribute significantly to CO2 emissions. However, with the rapid expansion of data centers, they are expected to use more carbon-intensive sources of energy, such as coal and gas, in order to meet their immediate and projected needs. The demand for energy from AI data centers has caused some utilities to delay the shuttering of fossil fuel power plants, and even resulted in proposed revival of retired plants or building of new ones. As is often the case with industry, the strategy seems to be build now, figure out sustainability at some vague point in the future. This is not something we should be encouraging. The chemical cost. Aside from the power and water cost, AI data centers also have a chemical cost, from cradle to grave. During the production of hardware, they require rare earth elements and metals, which are frequently mined in heavily unsustainable ways. And when they reach the end of their life, the hardware becomes hazardous e-waste, which can release toxic substances such as mercury and lead into soils and water, if not safely and appropriately disposed of. Due to the rapid speed of technological innovation, existing hardware will become obsolete long before its useful lifespan ends. A single data center could generate thousands of tons of obsolete servers every few years. Aside from taking up vast quantities of water, data centers seem to be disrupting groundwater and local waterways, meaning those reliant on well water may no longer have safe drinking water. There are also growing concerns that the water discharge from data centers has not been properly processed and decontaminated, leading to pollution of local waterways and soils. As with so many other concerns I talk about in this video, very little research has been completed on this topic, and it seems that current environmental regulations are utterly insufficient to tackle the problem. Air pollution is also a major concern. While data centers are of course not unique in this problem, as their numbers increase, so will their impact. Air pollution can affect health of both humans and wildlife in a few ways. Tiny particles, that's 2.5 or less micrometers in diameter, can travel far into the lungs and respiratory tract. As an example, within months of the opening of a new Mississippi data center, residents were reporting breathing difficulties and lung irritation, and noticed construction dust settling all across homes and schools. The area's childhood asthma rates increased, and they saw a spike in local NOx levels. Many data centers use PF gas or F gas, which is used in making products water, stain, and grease resistant. It is also a potent greenhouse gas, and exposure has been linked to a number of serious health problems, including cancer, kidney disease, birth defects, and decreased immunity. It is also one of the forever chemicals, as it does not naturally break down in the environment. At present, little to no testing has been done to monitor air or water pollution from this, and companies are in many areas not legally required to report the volume of their usage or discharge of this gas. What can be done about this? Much stronger monitoring and legislation is needed to protect the environment from the chemical cost of AI data centers. Stricter regulations and monitoring is essential. It is not impossible to properly recycle hardware and decontaminate wastewater. It's just that right now there are few legal or financial incentives for companies to do so. The emerging costs. Some environmental costs we are already reasonably familiar with, even if transparency and lack of disclosure mean that they are harder to study than they should be. However, there are a number of other environmental costs that research is still at a very early stage for, but what we know already is alarming. A recent study found that AI data centers raised surrounding temperatures by an average of 2 degrees Celsius, with a maximum of 9 degrees Celsius. And this heat island effect extended potentially 10 kilometers or more from the data center. The heat island effect is the result of the concentration of industrial activities, synthetic construction materials, and energy consumption. This is usually seen in densely packed urban areas and is known as the urban heat island effect. This heat island effect has an impact on local healthcare, water and air quality, and energy consumption. A number of factors contribute to this heat island effect, for example, a lack of vegetation and clean bodies of water, increased air and water pollution, and the heat retention and low albedo of buildings. The paper discusses several ways that this effect could be mitigated, primarily improvements to efficiency of both software and hardware. But research into this topic is still very new. This paper itself is currently in preprint. So at present, this issue is not being addressed by AI companies. Another poorly studied environmental impact of data centers are noise and light pollution. Noise pollution comes from various sources, including the rumbling of generators, the whir from fans, and the hum from cooling systems. And this is generally not regulated because noise ordinances are designed to handle things like loud parties, so the low-level ambient sound pollution is often not covered. Those living near data centers have reported headaches, sleep disturbance, nausea, vertigo, ear pain, tinnitus, hearing damage or loss, anxiety, hypertension, cognitive impairment, and even cardiovascular problems. This noise will also affect wildlife in a similar way to how sonar or boat engines impact marine life. On land, noise pollution can disrupt animal communication and health. Light pollution from data centers has yet to be studied in depth, but we know from light and sound pollution effects from other types of industry that they cause disruption and stress to the natural world. Much of this could be mitigated by improvements to equipment, cooling, and building soundproofing, as well as reducing light pollution being taken into account during the design of the building. But as with other problems discussed in this list, this does not seem to be a priority at this time. Along with the energy and water usage concerns, these pollution concerns are particularly pertinent, as a large percentage, 68% in the UK for example, of data centres are near protected areas or areas of key biodiversity, meaning that these data centres pose an increased risk for habitat loss, species decline, and environmental degradation. What can you do? Usually in these videos, I include a section of what you can do, detailing lots of proactive steps we can take both individually and collectively to solve a particular environmental problem. But honestly, the best option here is to just not use AI. Now, I could say to be mindful of your usage of AI, or use it sparingly, as many of the links in the description will advise. And this is of course better than using it with wild abandon. But I need to be clear here that all of the environmental costs I've just described still apply. So the only environmentally friendly option is not to use AI. I recognise this is easier said than done, particularly as it is increasingly inserted into technology whether we want it or not, and plenty of people are required to use it as part of their job, for example. I know many AI companies are now acknowledging that their products have an environmental impact and claim to be working on ways to reduce it. However, right now I see little evidence that this is any more than lip service and attempted greenwashing. There may well come a point where AI's environmental impact is reduced or even removed, but we're a long way from that being the case right now. Some AIs may have a lower environmental impact than others, but assessing this is extremely difficult for reasons we've covered a few times in this video. For the time being, the everyday consumer does not have any truly eco-friendly options. None of the issues discussed here are insurmountable, leaving aside unrelated issues with AI such as their legal, ethical, practical, economic, cybersecurity, psychological and neurological implications. However, at this time, AI still comes at a considerable environmental cost. One of the studies I've repeatedly referenced here argues that as AI infrastructure is so incredibly energy and water hungry, it should not be treated as software, but instead be given a similar regulatory environmental oversight as heavy industries. That paper also highlights that the lack of disclosures and transparencies of AI workloads in environmental reports means that it is difficult to assess and regulate effectively. If we want solid environmental regulations, we need to push for accurate numbers to be released, which would allow researchers and policymakers to accurately assess the situation with up-to-date data. Prioritising responsible land use with mandatory, robust biodiversity impact assessments and guidance sought in order to avoid habitat destruction or loss, particularly in high-risk ecological areas. If you want to make a difference here, once again, getting involved with various environment-focused groups can give you the tools to oppose irresponsible building of AI data centres, from signing petitions to contacting your local political representative. If AI is the future, let's fight to make sure it's a sustainable one. Conclusion. So I really hope you found this video interesting and informative. To sum up, AI uses colossal quantities of both electricity and water in deeply unsustainable ways. It is also responsible for significant chemical, thermal, sound and light pollution, threatening local communities and local habitats. I know I have my biases here. For example, I pride myself on not, at least knowingly, using AI for any aspects of my videos. I also don't personally use it, for a variety of reasons including the environmental cost. But I've done my best to present the information here as objectively as I can, and discussed ways that the environmental impact could be mitigated or prevented. If you enjoyed this video, please help me out by subscribing, liking, commenting, and sharing with anyone you think might find it interesting. So until next time, thank you for watching.